Hi, it's Miss Swinson again. Hey, here to tell you and talk to you about waves and energy transfers and all the things that you might be wondering about in your 8th grade year, um, home away from home, right? So the things I'm going to talk about today there are two things I want to talk to you. Oh, technically three things, but the third one's kind of like a side note. I want to talk about mechanical waves and the different types of mechanical waves. So there are four types of mechanical waves, but they're all categorized based off of the direction of the particles moving, right? So remember, mechanical waves are waves in which the medium, which is the thing that the waves travel through, is required, right? So mechanical waves in medium is required. So the way that we categorize mechanical waves is either transverse, longitudinal. There's also love waves and other waves that have to do with like different directions of the particles, movements, and like this. But so it has to do with the direction of the particles in the particular wave. So let's talk about first one. Let's go transverse. Transverse waves are waves in which the particles transfer from, well, wrong one, this one, from a 90-degree angle from which it started. So that means if the medium is, and I'll show you here, here's my little droplets of water. Let's do a side view here. All right, so the medium that we're talking about here is this water here, right? So as you can see that as it drops, the wave is going up and down. There's the crest, there's the trough. This is its frequency. We can up the frequency, right? We can make it happen more often, right? The waves come more often. We can lower the frequency. And we can change the amplitude, right? The amplitude is the height of the wave. Make it really large. But this is a great example of a transverse wave. So basically what happens is the energy is technically moving this way, right? And so the particles of the water are moving up and down and up and down, right? 90-degree angles from the direction of the energy, right? Energy is going this way, and the particles are actually moving up and down. And this is called a transverse wave. Transverse waves are particles that move 90 degrees from the direction of the energy, or from where it is created, right? So it created here, it goes this way, and the particles go up and down. So that is what a transverse wave is. A longitudinal wave, which is the second type of wave technically, is where the particles are actually moving to and away. So they're moving in the direction of or parallel with the energy, right? So they're condensing and uncondensing. Where's my sound? Right? So if I do sound here, we'll do particles. See, these particles represent the air particles in our world and the matter in which sound has to travel through. So if I do sound here, you can actually see the particles moving in the direction of the energy, right? So it's pushing away, it condenses and releases those molecules. Shout out to my doggo. Her name is Kiko. We call her Kiko, but her name is actually Keiko. She's a cool dog. Oh, it looks like Sparky's laying right next to her because he's special. He's a baby dog. Yeah, shout out to my dogs who are being really good dogs right now and not barking like they were, 20 minutes ago when I started making this video. I wanted to put together a different simulator for you guys, just in case you guys didn't quite understand the longitudinal one of the first section. So here is another example of waves and what they are right here. So we've got longitudinal and transverse wave simulator here. Shout out to whoever that guy is. So here's the simulator here, and you can actually see more clearer the condensing of the particles. And imagine this was your speaker in your headphones, right? And it's condensing the air, condensing the air, condensing the air, and condensing the air. And that's how you're listening to me right now, actually, is because electrical pulses are condensing the air around you. So it condenses and releases and condenses and releases. And then over here, it also shows you what a transverse wave is, that longitudinal, right? So obviously the energy is moving in this direction. And it's still, these particles are still moving at a 90-degree angle from the direction of the energy movement. All right, and lastly, I wanted to put up a definition and a small drawing of what each wave type might look like as far as mechanical waves. So this is a transverse wave, S wave, motion in which all points on the wave oscillate along paths at right angles to the direction of the wave's creation. Oscillate just means move. So all of the particles are moving like this. They're oscillating. So it's just the simple movement back and forth. So anytime that you hear oscillating, oscillating means moving back and forth, right? So all particles are just oscillating. With a wave, they're oscillating a little more. So the oscillating back and forth movement is at a 90-degree angle or right angle to the direction of the wave's creation. So over here, you've got the wave's creation, and it shows the direction of the energy on the wave, right? This way again, and then the particles in the wave are moving up and down and up and down and away from the energy that's being pushed along. And then we also have, come on. Oh no, it came up. Okay. Then the second definition is longitudinal waves, and these are waves where it's called the displacement. Remember when we talked about earthquakes, the displacement of water created tsunamis? So the displacement, which means all the particles get moved to a different location, and because of that, all the other particles also have to move to it. The displacement of the medium, which is air particles and sound, water in the depth of water, could be so many different mediums when you're thinking of longitudinal waves, you know, Earth, when we're talking about earthquakes. And the energy travels in the same direction. So over here, you've got the arrows of direction, right? And then you also have the direction of the particles. So these particles are moving back and forth, right? Longitudinal will condense or displace, and the other particles will just stack into wherever the empty space was. So those are the two definitions of mechanical waves. And like I said, there are other waves too, but it all has to do with the direction of the particle. So sometimes they're back and forth, parallel to the energy. Sometimes they're perpendicular, which is a 90-degree angle from the direction of the energy. There's more complicated waves. There's waves that actually move like this. It's called the love wave, and it moves like this. But if you really want to know more about the other types of waves that I didn't include in here, you can always Google types of mechanical waves, and it'll give you all the different types. So that's all for today. Have fun.